yeah, I'll just sort of record everything from here
Yeah,
on, and I'm assuming it'll probably put it in my drive or something. I got to figure out where the recording actually goes, and I'll just make sure I let my
most
students
likely.
know.
Yeah, most likely it will be drive, or even you have an option of doing it in YouTube. So recording will be automatically be in YouTube, but it will be private. Like nobody can see it unless you share it.
Right. Cool. Yeah. No, I'll share that with you for sure.
Sure. Thank you.
Yeah. No,
So
thank you so much. This is a cool program.
no, yeah, it's a cool program. Like I just after this I have been approached by another program from Switzerland about. So that is more about, so this is about school student, that is about after the bachelor's degree or the undergrad,
Hmm.
how people want to join PhD, so they have some doubt like how to find a suitable supervisor, something like that. So next week I'm doing that.
Awesome.
It's good. It's good because uh, when I was looking for PhD, or I have no clue.
Yeah.
So I have been in a lot of like what to do, how to do, and all those things. So if I can guide someone, that will be great.
That's amazing. Yeah, no, I mean, my high school kids are all getting ready to go to college next fall, most of them, and a
Yeah.
lot of them don't understand what research really entails. They don't understand what a PhD entails. They're just like, oh, I sign up, I get a PhD. Like that's just how it rolls. I'm like, it's a little different than that. And like one of the
Yeah.
questions that came out, he's like, how'd you decide you want to study on the liver? I'm like, well, that's a good question to ask to stop. Like that's a great question to ask somebody because I mean,
Hmm.
yeah, everyone has a different story how they get to that part. I'm like, I never went that far into it. I've got a master's, my master's in other stuff, but I'm like, yeah, everyone has a different story how they got to where they got to. So I mean, hear it from as many people as you can. Hear it from someone that's in the field researching. Like this will be good for these
Hmm.
kids. So I'm excited about that.
And what do you teach these kids?
I'm
Which
sorry, what was that?
subject are you taking? Which subject
Right
are
now,
you taking?
AP biology kids.
Hmm?
It's AP biology.
Okay.
So
And
advanced
like
placement biology. So they can potentially get college credit for it now. They have their AP exam in 2 weeks. Is there 2 weeks from today? Today's Wednesday. Yeah, 2 weeks from
yeah.
2 weeks from yesterday. Yeah. So
Okay.
they could potentially get a entry level biology college credit coming in. And if they're a bio major, they're going to have to take it anyway, so it won't really matter for them. But
Okay.
which I try to explain that to them, and their faces drop. They're like, "Wait, what?" If you're gonna be a bio major, AP credits don't really matter for you, bro. Like, sorry on that one, but yeah, this college is gonna get your money out of you somehow.
Yeah. And like how much knowledge do they have? Like so actually I have no idea about US. So how does it work? Like, do they know everything about cell biology, microbiology, molecular biology?
Cell biology is what we kind of focus on. So their AP exam is going to cover basic biochemistry, macromolecule stuff, cell membranes, cell organelles, cell function, heredity, genetics, gene
Oh, perfect.
expression. So like the
Okay.
epigenetic stuff, like that stuff I'm probably not as strong on as obviously
Okay.
not as strong as you are. So if you want to talk about that a little bit, feel free. Gene expression is the stuff they always have trouble with. But
Okay.
I think they may ask you more questions about college, but yeah, if we want to specific subjects, talk about specific subjects. I mean, they'll eat it up. They'll have a
Yeah.
good time with this. I hope.
Okay.
I'm gonna throw the link out to them right now. So give me one second
Yes.
here. Yeah, I saw you also specialize in epigenetics too.
Yes.
The link, just so you know. All right, just posted the link, so some kids will start popping up here shortly.
Okay.
So I told them
And
7 o'clock, so 4 minutes away. Someone might have set a timer for 7. So, but they should get notifications on their phone to start coming in. So, um,
okay. Perfect.
so you work with the epigenetics also. I saw that.
Yes.
What is that sort of with the liver where you're saying change certain lifestyle things and you can reverse the effects of it, or is that some other research you're doing too?
Okay, so so you must be knowing that epigenetics is something which is not encoded on the genome. So these
Right.
are the certain marks, certain modifications like acetylation, methylation on the genome, and the good part about them is they are reversible.
Hmm.
Generally, genetic changes are not that reversible, but epigenetic changes are reversible. And what we have found is that for the gene expression, these epigenetics plays the key role at various stages. So, and if we can reverse, so and these are very easily reversible. You can use drugs, or you can use some behavioral therapy, and they can be
So there's things we can
reversed.
do to manipulate the epigenome, like specific things we say, if you do X, Y, and Z, you can change your genome for this
Yeah,
manner.
yeah,
Okay.
yeah.
That's something I didn't know. I thought it was sort of more random, like, hey, what's going on in your environment? That's going to sort of shape it. But I didn't realize we could actually manipulate it too.
Yes. So that's what we are doing. Like for example, uh, my part of the my liver research is also applied to aging as well. What we have found that in liver diseases, especially for the fatty liver diseases, it's just the accelerated aging. So whatever the changes are happening over the period of age for about uh, over the period of years in fatty liver, they happen in case of few months.
Hey, Emily, how you doing?
I think her
Yeah,
mic is
my kids are
muted.
kind of shy sometimes, so she's
Okay.
probably waiting for some other folks to get on. That's all right, though.
Yeah.
We'll get her talking soon enough. There she is, high in the corner. Do you see the
I,
chat up there?
yeah. Let's wait for the others as well.
Yeah, we can hang out for a little bit. Yeah, no, that's exciting research stuff that you got going on there. Um,
Yeah, it's pretty exciting, but it's pretty challenging as well because
it's pretty.
nobody has done it. It's pretty challenging as well.
Oh, I can imagine. I can imagine. Emily, you're gonna have to hit that group text and start telling everybody, "Hey, let's roll."
I heard I saw in your email description that you are a Nevada licensed athletic trainer as well.
Correct. Yeah, yeah.
What is that? Tell me about it.
So when you watch sports and someone gets hurt on an athletic field, and there's a person that runs onto the field, we got a guest appearance by my kid and my dog back here.
Yeah.
Okay, put it down. That's fine. Thank you. Thank you. I don't even remember what I ordered on Amazon. What? Eventually, I'll get there. Okay. So when someone gets hurt in a sporting event, the person that runs on the field and tries to figure out what's going on with them, that's what an athletic trainer does. That's we call them athletic
uh,
trainers in this country. Some other countries call them physiotherapists.
ah,
So
physiotherapist. Yeah.
same kind of idea there. And
Okay.
I've been doing that one for a while, and yeah, just sort of that's what I got my start in. And I moved into education after that because I was working at the high school as the athletic trainer for the various
Ah,
interscholastic sports here, and then I
okay.
transitioned teaching full time. I also teach at UNLV, University of Nevada, Las Vegas. Hey, Joey, and
Enjoy.
I do a sports med class at University of Nevada, Las Vegas, so emergency management of injuries and illness. And
Oh,
that
okay.
sort of got me into this whole EP bio thing when I started teaching at the high school. Um, they were like, "Hey, you got kind of a science background. You want to do AP Bio?" And I was like, "Not really. I'm not gonna lie."
Okay.
I was like, I gotta learn some stuff here before I start teaching AP Bio." But I've been learning this stuff. I've been doing this class now for about 6, 7 years. So I've
Wow.
read the book
You're
back and
pretty
forth time. So getting
okay.
better at it and trying to improve my game all the time.
Good.
Joey's
That's
one of my
great.
early
So
students that
which
actually said she wants to
yeah.
research. So I figured she might enjoy this a lot too.
Okay. I'm looking forward to it. I
Yeah.
hope I can inspire these kids. I
Uh,
hope. At least I will try.
I'm sure we'll be good.
So which sports do you generally go for your like for your training?
So at the high school, we had football, baseball, softball, men's and women's soccer, track,
Okay.
volleyball,
Mhm.
basketball. I do a lot of wrestling stuff. Wrestling is kind of the
Wow.
niche I sort of worked my way into. I've done some
Okay.
international stuff with wrestling, so that's been pretty cool.
Wow.
Yeah,
Seriously? Okay.
I've got to travel with Team USA, which is pretty wild. So that's kind
Oh,
of fun.
nice.
Yeah,
Nice.
that's my fun job. That's one where I
So
get to do.
you're pretty much kind of all rounder. You do with the sports, then you have your teaching stuff going on well, and then
Mhm.
wow, that's cool.
Try to keep myself busy.
Yeah,
Let me send another message out here.
it's okay. Like setting up might take some time.
So I know we had about 8 people on yesterday that they said they were going to come in. So hopefully they'll get here shortly.
Okay, okay. Emily said I'll text people. I'll text people.
Yep. Oh
Mm.
man, they got text going. They make fun of me all the time in those things. I can imagine.
It's like that. So even I am like so we have to do some teaching assistant with the professors, and also I have taught some kids here like some basic fundamental experiment biology, genetics, and all molecular biology stuff. So they're actually pretty fun to. You actually learn a lot with these kids because they ask you some questions which, okay, I have never thought about it. They will ask you, and then you learn with these kids. So it's pretty much fun.
Trust me, my one Joe, my student down here, Joey, has asked me some questions I've had to look up many times. So yeah, it definitely keep me on my toes. I'm like, you know what? That's going to go on my board. I'm going to have to look into that. If you know anything about endothermy and transposable elements, yeah, we're going to have to talk about that one because that's on my board looking at me right now. Um,
Yeah.
yeah,
Okay. I have a basic idea about transposable elements. Maybe we can deal into this later.
awesome. Well, I'm hoping more will join as we're going, but why don't you sort because I know you're probably on a time crunch here. I know it's the morning, so you're probably in the middle of a work day, I'm assuming. So if you want, how about just sort of get started talking about yourself, talking about where you're working and what you're looking at. And I'm sure these two can provide some good questions for us to sort of keep this flowing and I'm sure more people to start joining in as we go. Keep texting, Emily. Thanks.
Okay. Because just two students are there, and shall we just wait for 2 more minutes? Maybe
Okay, yeah, we
people
can
will.
do that. Yeah, we can do
Okay,
that.
let's wait for 2 more minutes.
I'm curious what I got. I have no idea what I ordered. Oh yeah, I remember that now.
Yeah.
How's the whole virus thing out there by you guys in Singapore?
Uh, Actually, virus here is a bit controlled, but recently my sister got. So I'm from India, and my sister got infected with COVID-19
Oh
2 days
no.
back. Yeah, so it's a bit tricky situation over there.
Yeah. How are they trying to contain it and control it? And is it contained controlled in Singapore or what's your guys' status with it?
So here in Singapore, it's all about containment, and they trace a lot. So they have asked us to install an app, which is kind of Bluetooth-based device, and that's how we just track everyone. Uh, and in Singapore, it's not a big deal because people actually follow what government are saying. They are very, yeah. So the local, the major hub or the major hotspot is between the foreign workers, and like they are almost all of them are being affected with COVID-19. Apart from that, in the local community, there is not much cases as such. Like only less than 10 cases are coming up daily. So, but
Hey
in
Gary.
India, it's increasing.
Yeah, India I heard was starting to increase a little bit. They kind of were, they didn't have it for a while, and then all of a sudden, the last few weeks or so, I've heard it's starting to
Yeah.
tick up a little bit there. Where in India did you come from?
So in India, I'm from a city of Agra. If you heard about Taj Mahal,
Hmm.
uh, so I'm from that city.
Okay.
It's near New Delhi.
Okay. So you grew up seeing the Taj Mahal like it's nothing, and you're just like, yeah, Taj Mahal, done.
Yeah, just like okay. So let me see if I have some slides from.
That's kind of like these kids with Vegas. Everyone freaks out when they see the lights in Vegas, and we just sort of walk around like, oh, yeah, it's this is home.
Yeah, yeah. Actually, I've been to US October last year, but
Oh,
I just visited Chicago, New York, and New Jersey. In New
Chicago's
Jersey, I was yeah, but
that is where I came from. I love Chicago. Too cold going.
Chicago.
Yeah,
Okay, now, it's a very nice city actually. It's beautiful.
it is. It is. The architecture
Uh,
there is crazy.
yeah,
Crazy
but
buildings.
the winds over there was like really strong. I've
It
never seen winds like that anywhere. Like they were like literally blown you away.
surprisingly, Las Vegas has wind very similar to that too. I mean, because we're in the middle of a valley, so when the wind comes through here really hard,
Huh?
it's hard. Like it'll be completely calm, still all day, and then all of a sudden the warning thing will pop up on the phone, and you start hearing the terrible noise, and it's the emergency weather service, and then this massive wind just comes through, and then 20 minutes later it's gone. It's weird.
I see. Okay. So shall we get started?
Absolutely.
Okay. So let me just give you a brief introductory slide. Let me just share my screen with you.
Perfect.
It's a bit slow. Can you see the screen now?
Haven't gotten it yet.
Okay.
Oh, here it comes. There we go.
Okay, so this is just a presentation I did for 3 minutes in my in last semester. So, uh, hi kids, hi Mark. I'm just gonna share briefly what I do, and then we can take out from there. If you have any questions, I will be more than happy to answer. You can stop me wherever you want. And okay, so here it goes. My name is Ankur Sharma. I'm a PhD student at NTU Singapore. I work with a lot of genomics, epigenetics. So the question I'm asking here, and what I'm sharing here is related to the fatty liver diseases. It's a fatty liver disease is a disease where a lot of fat are accumulated inside your liver, and almost 2 billion people are affected by this disease. The worst part is it's a silent killer, and there is no drugs available. So in fatty liver, if you break down, if you can see my cursor, there are different stages. Like the normal liver looks like this. In steatosis, you can see this triglycerides building up. Mark told me that you have some biochemistry background as well, so you know what is triglycerides, right? There are three glyceride molecules combined together. So there, that stage is steatosis. Then in the NASH stage, there is a lot of inflammatory reactions going on because the immune system is getting activated and it kills the cell. There are a lot of collagen fiber formation and which eventually lead to cirrhosis. And this is the end stage where up till this stage the fatty liver is reversible. But once it is enters the cirrhosis stage, the only hope for a patient to survive is a liver transplant. Uh, the problem is it's a silent killer because you never know you have a fatty liver until at a very late stage because there is no symptoms as such. So that becomes tricky because once you have already in the late stage, the chances of survival are minimum, so you need to diagnose it before that. The problem is that the only gold standard method which we have right now over the world is biopsy. What happens is biopsy is like you cut open the abdomen cavity, take out a piece of liver, put it under the slide, or with the help of a needle you take and put it under the slide and study under the microscope, and you see like whether you have fatty liver or not. This certified people, a certified doctor will be able to tell you whether you have fatty liver or not. But you see, the problem is it's invasive, and you cannot do it like over the period of time. So you need to figure out a way how to do it non-invasively. So with that idea of mine, I started my PhD research. Uh, if you can see, like these are the different stages in humans. So I developed mouse model, and these are the livers which is taken from these different stages of fatty liver mice. Uh, it might look a bit gross, but you have sometimes you have to get your hands dirty. So at different stages, I was able to develop. I was able to detect fatty liver, and using these my models, I developed few biomarkers which can detect the fatty liver non-invasively without any surgery. Also, this gives me insight about what is the mechanism, how this stage is getting transferred to this and this to this, what are the changes. And my research, I have found that they're not only genetic changes, but they are epigenetic changes. And those epigenetic changes are basically driving the gene expression changes inside the different stages of fatty liver. Uh, so the idea is like how I'm detecting fatty liver is that I'm injecting the mice with activator. It's kind of a molecule which goes into the liver and activates the biomarker which are already expressed by the liver. Then we image the mice under the camera, and then using spatial software we reconstruct the image. Uh, so once we reconstruct the image, we get something like this. So if you see here, this is a normal mind, and this is stage one, and this is the last stage. So you can clearly see that the expression of these biomarkers are very low. This is a scale are very low. Most of them are blue. But in case of end stage, which is cirrhosis, the expression of biomarkers are very high. So using this, we can in a very real time manner, we can detect what stage of fatty liver you are in, and also in non-invasive manner. So using these biomarkers, I'm trying to. Uh, so this we have validated in some few patient samples, and but we mostly they were issues. So we are kind of looking into cohort where we can get some non-Asians patients as well and test these biomarkers. If you have any questions, this is more about like a general idea about what I do. Uh, uh, I will be happy to answer if you have any questions.
Are the biomarkers found in blood, or how do you find the
Uh,
biomarkers?
Okay, so what I did is uh, these biomarker are kind of so from the liver I have done RNA sequencing. So this RNA sequencing I have find the genes which is getting upregulated in different stages of liver, and those using those genes I have selected like these are the biomarkers because those particular 5 or 6 biomarkers are highly specific to particular stages. So those were my biomarkers. This can be at the protein level and that can be the gene level as well.
So you're looking for, depending on the stage of fatty liver disease they're in, there's going to be more or less of a certain protein being made, and that's sort of what you're looking for.
Uh, Mostly my biomarker are RNA. So these are mRNA. So
Okay.
how transcription,
Okay.
mm,
They should know what that word means.
transcription.
Yeah, they better know what transcription means.
Yeah, yeah, yeah. Of course,
They
I
better know
know.
what that word means. Hey Dillis, how you doing?
So, do you have any questions?
Yeah, there's some questions out there, guys. You can throw them in the chat, or you can unmute yourself and actually ask Dr. Sharma here, and he's happy to answer. He's took some time out of his day, so please ask away. Doesn't have to be about the liver. You can ask him about ask him about the process of research. You can ask him how he
Yeah.
chose the liver, anything. We were talking for about 10, 15 minutes before you guys started coming on, so he's got some good stuff to say to you.
Okay, so Emily asked a question. What made you choose to research the liver over other organs? Okay, that's a very good question. Uh, so liver is special organ. Inside of a body, liver is the only organ which can regenerate itself. What I mean by regeneration, you must have seen some lizards, right? Their tails might grow off, and then over a period of time, they can regain their tails. So that kind of process is called regeneration. Inside of a body, only liver can do that. And how? So, like, if you even cut the 75% of the liver or 70% of the liver, the rest of the liver can grow in size to give rise to the exact 100% mass, and that is pretty awesome, right? Also, so generally your life, the lifespan of your cell is roughly about 100 days or something, like if you talk about blood cells. But liver is special, like it generally it lives about 300 to 500 days.
Oh wow.
So, so lifespan is there. Also, liver has a very important property of polyploidy. What I mean is by polyploidy is generally you must have studied in your biology the classes that cells are diploid. What I mean by diploid is that they have two sets of chromosomes. That's why we have total 46 chromosomes or 23 sets, 23 pairs, right?
Right.
Uh, but in liver it is different.
Wait,
Majority
what?
of the liver it is different. uh, because majority of the liver cells in all the mammals they don't follow this norm. So when other cells are 2n, liver cells are 4n, 8n, 16n. So they have 16 set of chromosome, they have 8 set of chromosome, they have 4 set of chromosome. And
Is it
this,
always sets of 23?
or yes, all these sets of 23. For humans it will be 23, for mice it will be 20. For
Okay.
different species it will be, yeah.
Right. Right.
And so this polyploidy is mostly related to cancer, right? If you see, like generally
Right.
you see that cancer have this abnormal genome, but if polyploidy is the how should I say is the threshold value for cancer, then all of us should have a cancer because all of us. I'm sorry if I make you. Yeah. So If polyploidy is responsible for cancer, in that case, all the mammals on Earth should have liver cancer, but that is not the case. So, liver has some mechanism to control this polyploidy and still be healthy, still be functioning. So there has to be a all these things question actually gave me. So liver can serve as a model to study aging because the lifespan of the cells is good. It can be served as a model for regeneration because it is the only organ which can regenerate. Maybe we can once upon a time cut our hand and maybe it can grow like some organisms can do. So that is
Yeah.
thing. Then liver can control cancer, and all these things give us a very detailed things about how we can tackle three different situations, three different questions for the mankind: regeneration, aging, and cancer. In choosing just if we can study one organ, and maybe it can give us more insight about it. Also, there are a lot of diseases, like as mentioned, like liver cancer and fatty liver disease. These affect billions of population all over the world, and we don't have much knowledge about it. Liver is so important organ, like it performs more than 600 function inside our body. And if you must have seen that all the end stage liver, all stage cancer happens when they infect the cells got metastasized in the liver, and that's where the body gave up. Liver is so important for the body that once it is affected, your body starts to degrade. So all these things prompt me to ask this question in terms of liver, but which can be applied to biology in general.
That is pretty freaking amazing. I actually learned the regenerative part the other day watching a TV show. I wasn't sure if it was true, but now that you've confirmed it, I feel a lot better. Criminal Minds again. I always talk about these guys about Criminal Minds. Dr. Reed mentioned that yesterday because there was an episode about liver transplant patients. I did not know about the polyploidy in the liver. I had no idea about that. Is
Yeah,
that a
that's
mistake?
one of the.
Is it a mistake that's going on in there where there's a problem with mitosis or something, or is it just normal for the liver to go through it? Like what causes that?
Exactly. So actually, this is very common. Like what I've heard, if you talk about heart cells, heart cells are mostly tetraploid. In liver, it's very different. For some organism like us, 30% of the cells are tetraploid, like 4N. In mice, it's 90%. Up to 90% of the cells are tetraploid.
Oh wow,
Tetraploid plus octaploid, so like
quadruploid.
polyploid. Okay, so how it happens in different organs, the the mechanism is different. For liver, it is incomplete cytokinesis. So what happens in the mitosis, the final stage of mitosis, cytokinesis, where the furrow formation happens and the daughter cells kind of divide. So that process is hindered in liver. So there is a very well studied mechanism over especially during the last decade, scientists have been extensively studying that. So what we have found is that the cytokinesis happens. The cytokinesis does not happen. Sorry, my bad. And that's how the cells. So after the mitosis, like during the metaphase and the anaphase, the the genome has been duplicated. Like if it is a 2N cell, we already have 4N cells. But since the mitosis doesn't happen, so now we have 4N cells within one cell boundary. And that's why you see a lot of binucleated cells in the liver because the metaphase place had been separated. But somehow, yeah.
Oh wow, that's wild.
So, so inside one liver cell, there are two nucleus. So there are binucleated. Also, there can be one nucleus. So there are mononucleated. And what scientists have found that the expression of genes between binucleated and mononucleated cell is also different. So there is a lot more complexity. Also, I think I forgot to mention my bad. There is a property of zonation. So metabolic zonation. So what happens in case of liver that I don't know if maybe I'll take the example of this E symbol over here. If you can see my cursor, so liver actually have a lot of blood vessels. So suppose this mic symbol over here is the central vein, and this minus symbol is a portal vein, for example. So blood flows from here to here, and because of this blood flow, there is a kind of a gradient of oxygen, of some nutrients, some hormones, and that's how. This part of the liver do a particular function, and this part of the liver will do a particular function. Like this is a normal cell, right? So no, not a cell, but it's a lobule. So liver are arranged in kind of a lobule structure. So this
Right.
part of the lobule will do some function, function one, and this will do some function two. So this is very unique. Like we don't see this kind of zonation in other organs.
So
So
it's
this
got
is
like
one
little
of the
compartments in the organ that all do their own little job.
yes, kind in a way yes, but because this lobule is distributed throughout the liver, so like all the lobules are doing a particular function.
Okay. Cool. Cool. Keep throwing some questions in the chat, guys, and you can keep typing while we're waiting.
What is your so Gary Chen had asked, what is your favorite part of being a geneticist?
Geneticist.
What convinced you to explore this path instead of other careers? Okay, Um, to be honest, I don't know like whether I'm a molecular biologist or a geneticist or genomics expert or whatever. I just uh, I this question seemed interesting to me, and I thought like maybe I should give it a try for my PhD because it's very amazing. And it has so many layers, so I decided to dwell into that. When I joined my PhD, I have to give a proposal, and I came across few papers about liver polyploidy as such. So I asked my supervisor, "Can I work with it?" And he said, "Okay, give it a try." And my initial findings, it's always a beginner's luck. So my initial findings were very encouraging. So I continued with that. Uh, Let me check the question again. The question was, what convinced you to explore the path instead of other career? Uh, if you're talking about my PhD, is like I was actually after my bachelor's degree, I was working in a biopharmaceutical company, and I was developing some anti-cancer drugs. If you know, like leucovorin calcium injection, which is basically an drug to deal with the side effects of methotrexate, which is one of the major cancer anti-cancer drugs used in chemotherapy. Uh, and somehow I was feeling that yes, I'm doing a good thing, like I'm producing drugs, I'm defining the process, but I wanted to do something basic research to, you know, it's a personal choice. Like I wanted to learn more, I want to dwell more. How now, what I was doing over there, I was testing the method. How can I purify this drug and how can I make it more potent? But I wanted to know the process of how to get this drug on the first place. So that comes as a basic research. So that's why I decided to go for I write my international exams and national exams, and I got somehow God's grace I got some good grades, good score. So I got enrolled in good universities in my masters and here in my PhD as well. NTU is one of the top. I think it's 11th in the world all over in terms of ranking, university ranking. So I got lucky in that case. Uh, and yeah, that's more like I wanted to do research, so that's why I decided PhD. But having said that, please consider it. It's a very big commitment. I would not say like PhD is easy, uh, especially if you're moving into a different country or if you're going outside your comfort zone. Uh, you have to be. It's not just how brilliant or how smart you are. It's about how patient you are, how well you can deal with the failure, because trust me, there will be a lot of failures. Because uh, what I would like to uh, tell you is that I read it somewhere that PhD is a process of breaking yourself and then picking up your pieces and redefining yourself. So it's very challenging. Like for me, one of the major challenges I faced was I have never learned much into programming. like R and Python and Linux. Uh, but for my PhD, that was in like very very important. So I with like I I was lucky, like there are a lot of courses available online, but it's very tricky because when you do something for the first time, you don't know whether you have done it correctly or not. And one of the most important thing about science is like you have to be your own critic. You
Mhm.
have to find problems in your research and your work before anybody else could find it. And uh, so you have to be confident in your research, but at the same time, you have to be your own biggest critic. Like find faults in yourself, in your work, so that nobody else dare to find it.
Absolutely. Absolutely. One of my friends is one of the docs at UNLV, and she said when she was doing her PhD research, she reserved at least one day a month to crying underneath her desk because of how many times she screwed up and failed. She's like, it's just normal. You cry under the desk, you talk to your advisor, you go cry again, and then you just get back up, and it's just a story of perseverance. Like you just got to keep going and going. So I always think about that because I was debating on it at one point in time. Still haven't closed the debate yet, but that might be down the road one day. What was your bachelor's degree in?
So I did my bachelor of in technology. It's BTech. It's kind of engineering degree in biotechnology.
Okay.
So apart from the interesting thing is like in my school final, so we have 10 plus 2 system. So my 12th is the final. I don't know about. I think US it's the high school and then you kids go to college.
Correct.
Is correct? So we have something like that. It's 12th standard. We call it intermediate. After that, we have to go to college. So in my intermediate, generally people choose the subject they want to do. So I had physics, mathematics, computer science, and stuff like that. I didn't have biology, but for my undergrads, I chose biotechnology. Again, it was like I have no idea. Like all kids around me were like pretty smart. They know everything, like how what is biochemistry, what is molecular biology, because they have been taught about it. I have no idea. I was like, how do you know this? So that was pretty amazing. But yeah, I have to
So you were a biology
study.
rookie going into college.
Pardon? Yeah,
Wow. Wow, that's impressive.
yeah. So yeah, and now I'm doing a PhD in biology. So it's pretty.
Come full circle.
Yeah. Okay, I have got one more question from
That's Dillis.
Wing Chuang. Right? Did
Dillis.
I pronounce it correctly? Dils.
Dillis. Yep.
Yeah. Are internships and lab hands-on experience during PA critical for biotech biochem jobs? Uh, Actually, I would say yes, eh, because when you have a hands-on experience and internship, it shows that you have shown shown interest. Also, like when you do an internship or in a generally you do an internship in a something similar company or some similar profile which you are planning, or you can do a lot of internships and figure out like what do you like most. This gives you see study our atmosphere in study or in the school is very different from what is out there in the professional world, especially in industries and all, because they are very professional and everything is very pipeline and streamlined. So definitely you have to gain experience about it. If you can find a good internship, that will be great. Some are paid, some are unpaid. So you have to ask the manager, the hiring manager, whoever it is, like how much you can be paid and all these things. Internships, if you are considering working in a company, definitely try to secure a internship in that company or something similar to that because generally people hire people in the company within the company, so they just send around an email within the company first, like I have a position, do you have someone in mind, and then if your manager or if your colleague recommends you, your job gets easy. Also, like you we as in school we have a fantasy of oh, this will be so cool when you do the job in internship, you get to know, it is it may or may not be that cool what we are thinking. So you get a realistic view, holistic view about it. So definitely go for internship. Labs hands-on experience. If you're more focused about research, definitely go for the labs hands-on experience. First,
Nice.
if it will give you an idea about how to do, like for example, running a PCR seems very simple, right? Like there is a three-step, there is a denaturation, annealing, and extension bit. That's it. Seems like pretty normal job, but let, let me tell you, like even postdocs which have 20 years of experience, sometimes they struggle with a certain set of PCR because it's not that easy. Biology is not like math, 2 plus 2 equals to 4. No. In biology, there are a lot of variations. So getting your hands, working on the pipette is crucial. Uh, how not to contaminate samples is crucial. Designing an experiment, how you can, do 400 PCRs in one go. You have to like think about it. So it gives you a lot of things. So definitely, if you're looking into jobs like industrial job, go for internship. Definitely go for internship. If you're looking for research, go for lab experience. And let me tell you one thing: most of the professors they will love to have you. It's just that they won't be able to give you much time. That is, if they are big shots, like if they are very well known, they may not be able to give you time, but they will give you some space in the lab, and you have to get your way over there. Some labs have defined structure that if an intern comes, then who will deal with it, and they get some some hours for that. Uh, some labs don't have it, so you have to whatever someone is doing, you just learn that. But definitely go for it if you have time, if you have the opportunity, go for it. Uh, and I think in US the labs are pretty awesome. Like MIT, especially in Boston, New York. I have no idea about Vegas. I'm sorry, but I'm sure there must be some good universities in Vegas as well. I think Vegas. I have no idea. Sorry.
That's okay. Great questions and great answers right there so far. Very good stuff.
I think I've got one more. Oh, thanks.
I should just say that. Yeah.
Welcome. Yeah. What might be a typical day of work looks like? So I think Jofi, is
Yep.
it correct?
Joey. Goes by Joey.
Joy.
Yeah.
Okay. Typical day and work looks like. So right now we are in the shutdown. So I will tell you before shutdown what we were doing is like I generally reach my lab around 8:30 9 a.m. Generally around that time, but I might go early or late depending upon my schedule or experiment or my previous night uh, you know thing. Uh, and then I go over there and so generally, I do two kinds of work. So one is called wet lab and one is called dry lab. Wet lab is the part which I do in the lab using pipettes, and if so, for example, PCRs and all those things. And the other dry lab is the analysis part, which I do um using my computer. I use R, Python packages to run the analysis on my system. So mostly, what I try to do is like I try to do my wet lab part first because that's very time consuming. For example, if I have to do a qPCR, qRT-PCR reaction, so in the night before I already have planned everything. Like these are the ingredients I marked it if I have it or not and where it is, and then a chart. So for qPCR generally we do a lot of controls experiment as well. So generally it's a 96 well plate, or it can be more than that, 384 well plate depending upon the experiment. So I have already figured out. So I prefer to figure out in Excel sheet or something that plate number one will be sample this. What is so something like that I've already prepared. Then I go and set up the reactions. And once the setup the reaction is going on, so it takes like 2 to 3 hours depending upon the reaction or whatever. So during that time, I come back. If I have some paper to read, I read that paper. Or if I have some analysis to be done, I do that analysis. Once the PCR is over, then I take out the data. So what I generally do is for qPCR, you don't have to, run a gel, but I prefer to run it on a gel because if you
So
if you
you run it
know,
in an electrophoresis chamber?
but
You run it in an electrophoresis chamber?
Yes, gel
Cool.
electrophoresis. I
We
use
do
gel
an
electrophoresis.
electrophoresis lab. We have not done PCR labs, but we have talked about PCR, where you amplify the sequences of DNA, correct?
Yes. So
Okay.
actually, if you're doing any kind of biology related experiment, I would say 70% of the time you will be running either a DNA gel, which is electrophoresis, or a protein gel, which is SDS phase. So if you get your hands on, especially for kids in school, if you really can get your hands set on that will save you a lot of time, and that will make your life easier, in especially in labs.
Yeah. It's all about making your life easy in the lab. I like how you talked about preparing it the night before, making sure you have everything already measured out. And because
Yeah.
when we're doing the labs in here, and like we do two biotech labs. We do electrophoresis and we do a transformation with a bacterial lab.
Oh wow.
And
Okay.
like I take some volunteers and they come in and they set up all the plates and just get everything ready. So when we come in, we can just get ready and roll.
Hmm. So after that, I think I go for lunch with my friends and I come back. Then it depends if I have analysis. So again, for example, I go for lunch for about an hour from 12 to 1. Generally, I go about that time. From 1 to 3, uh, it's a time where I'm more kind of sleepy because I just had lunch. So during that time, I generally plan to work in the lab. Either preparing some reagents for future experiment or doing some experiment because that's keep me running around and if I sit on my bench, I will sleep for sure. So I just prefer to be physically active that time. Generally, we have some seminars, so around 3 to 4 p.m. If we don't have any seminar, if we have a seminar and it is related to my interest, I will go and attend it. Uh, if there is no seminar or the seminar is no interest, I don't do that. So from 3 to 5, 5:30, I either prepare for the next day or work on my thing, whatever is left. So I generally have a to-do list. It could range from how much I have to do. If it is I'm doing something for the first time, I prefer to keep the list to only three tasks per day. If I know, like if I've done some experiment multiple times, so I can do 5 to 8 tasks depending upon how much time a task will take. So it's all about planning ahead, planning everything in advance because you uh, pop up things will pop up for sure. Like your lab member might need help from you, or your supervisor might ask you to come in his cabin and work or discuss with some results or something. So you have to be flexible with that. And generally, we have a tradition of going to a tea or a coffee break around 5:30, 5:30 around. Then we discuss about anything, like may not be work, but personal life. If some event like lately, we are discussing a lot about COVID-19 situation and that a lot of therapies which is coming up. And then I just plan around 6:30. I like plan schedule everything for my next day or next week or whatever. Then I go. So I live in the campus, so I generally walk home and start preparing my dinner and all, and just talk to my friends and my family back home. This is a typical workday which looks like for me.
Awesome. Thank you. Oh, I talked to me, Mr. Dianza talked about how my friend cried on her desk when she failed her research. How do you cope with failure? What motivates you to continue research after failing or messing something up? So what keeps that drive going to keep researching?
Okay. Uh, to be honest, initially it was very difficult. Initially, like I because till my masters, like I was my experience was like everything works in one shot, 1 or 2 shot. Like because to be honest, I was doing very easy stuff like running a gel or analyzing some Western blots or transformation. These are pretty simpler work because you pretty much standardize like whatever you do. If millions of people have done it, and there are protocols like if you add this thing, and because you were taught everything details about it, so it was like most of, I would say my success rate were close to 90% like in my experiments. I was like, this is easy. But once I come to my PhD, uh, my experiment starts to fail, and even though the experiment which I have done previously, and it was pretty challenging, it was heartbreaking, and it gives you the impression. So there is something called imposter syndrome, which is like I'm not good enough. Maybe I'm not good enough. Maybe I don't belong here. So almost all these students I would say have those same feelings. They have similar experiences. But then I would say like you when you talk to your friends, you talk to your landmates, you realize that it's not just you. Yeah, everybody has seen those challenges and all. So the thing what I have learned is like things will fail for sure. Even if your things fail, even if your experiment fails, you should be able to come up with the reason why it failed. And once you come up with the reason why it failed, then you win. It's not your loss. You learn something. Uh, because what I have observed is like, for example, for gel electrophoresis, so it's a very stupid example I'm sharing with you because you should know that nobody is perfect. Even everyone makes a silly mistake. So in gel electrophoresis, like you must be knowing that we generally use TBE buffer or TAE buffer, right? Boric acid, EDTA, this buffer. If you don't use, so I was working like very late night, 2 a.m. around. So instead of TAE buffer, I used water to cast the gel, and the gel shrunk. And
Oh
I
no.
have no idea. I have no idea what went wrong. So and my samples were lost. So I just loaded it and I just came home. When I went next morning, I like everything is like missed, and I thought like, oh my god, what happened? So these kind of silly mistakes happen. But then I realized that I made this mistake, and now every time I cast my gel, somewhere back of the mind, it's always there. You have to use TAE.
Make
So
sure you
that
use the
mistake I
buffer. Always use the buffer.
yeah.
Yeah.
So all these things. So uh, of course, it's very heartbreaking. It's very challenging. I will not say like, oh no, it's not easy. It's not easy. To be honest, it's not easy, and it should not be because you are pushing the limits of human knowledge. You are discovering something new which nobody has worked on. If it was easy, anybody would have done it. Right? It's not easy. You have to accept that fact and give credit to you that you are doing something probably other people have considered impossible or unimportant. But now you're focusing your brain, your whole attention, your whole efforts to it, and you may or may not get recognition for that. You have to accept the fact that you do something for the love of the game, not fame. It's a famous dialogue which I heard from Pankaj Advani, one of the world champion in billiards. He's from India. So I think maybe 10 years ago he said that do something for the love of the game, not fame. And when you do something, and also like don't choose PhD uh, for your parents, for your peers. No, it's very challenging. Do something if you really want to be inside, if you really want to do a work, you do. If you're good at sport and you enjoy sports, do sports. Don't care about anybody like or will say, oh no, you are not good. And I would say a sports person has equal talent and recognition as and a scientist because both are brilliant in their own field. So do what you want to do, really want to do, and focus on it. And eventually, when you keep pushing, things will fall apart. Things will fall apart initially, but things will start to fall back again in fail. When you fail an experiment, try to find out what went wrong. If you cannot just repeat the experiment with some different control, always use control for any experiment. Very important, especially in biology. You should have a positive or negative control. Sometimes it's not possible to have a particular control, but that's okay. And um, yeah, yeah. Sometimes you try that you can have it. Everybody very lucky. Uh, so you talk to your friends. Sometimes you feel ignorant, you talk to your friends, maybe your parents, depending on how your relationship with your parents or not. Talk to your friends, talk to your supervisor, or sometimes just leave everything and go for a movie, go for a you know, if you like soccer, go play soccer. If you like reading books, go read a book or play video game, whatever. Take a break, come back again, but do it. Yeah,
That that
I think.
is that is great advice right there for these guys.
Yeah.
Cool. We'll do one or two more questions, guys. We're getting close to an hour on here, and I know he's got stuff he's got to do today. So, if you got something you want to know, now's the time to throw it out there.
What is your opinion of COVID-19? Opinion. It's a very infectious disease. I would like to disagree with your President Donald Trump in this case. It's very infectious disease. It's contagious, and you should try to break the chain. So you must have heard about flattening the curve. Uh, you must have seen two curves, like one is peak and one is the broad curve. That essentially means that you you should try to have social distancing so that the number of cases don't surge at one point and your hospitals are not overwhelmed. Uh, I don't believe it's some country or some individual has done it intentionally. I would like to believe that no human can be that cruel. Uh, hopefully I'm right. Hopefully I'm right, but
Yeah,
I have no
exactly.
idea about. Yeah. It's it. Uh, I would like to give credit to researchers, doctors, researchers who have done tremendous amount of work.
Hmm.
I think we are very close to get our first vaccine in a couple of months, and that will be the fastest vaccine in the history of mankind. So, due credit to them. People are working really hard. Even I was analyzing some COVID data some days back, and it's really good. Like I would in some part of the world we see a very improvement, a vast improvement in some part. Uh, we still have a lot to do, and maybe this is something which reminds us that you are not above nature. Nature can manage you anytime, any. So like generally what we see is like we try to manipulate nature and nature can hit back. This is my personal opinion. This is nature hitting you back and showing you what you are in this, on this earth. Uh,
Mother Earth slapping us a little bit. Like,
but
hey,
yeah, I would say like if you are more asking about the vaccine part, I would say like we are still uh, we still don't have it. I think Israel and Italy. There was some report from that, but I haven't seen a human clinical trial. I have missed it. I don't know, but I have not seen any human clinical trial. But Israel, I've heard about. They have conducted experiment on mice. Again, mice is not that. Uh, most of the vaccines, which we, or most of the drugs, which is approved by FDA, the first stage is like animal models. So most of the works which work on animal models may or may not work on humans. One little worry about it, and of course, like in hydroxychloroquine, uh, what Donald Trump has suggested, it was based on a in vitro data, that is, it's a cell line model, what scientists have published. And course, it is not very confident. I was very surprised that even in vitro data, how he, yeah, he publicly said that it will be able to cure COVID-19, and of course, you see a lot of side effects. It's not working, according to my understanding and whatever I have read. If I missed some recent piece of literature, it is my bad. But whatever I have read, it's not very effective right now. So in India, what we are doing is something called plasma therapy, and it is very recent, and it is, I would not say very statistically significant, but whatever I have read in the newspaper about statement of government is that it's working. So plasma therapy is essentially what. So from the already recovered patient, you collect the serum and you put that in the person which is affected. So it's kind of building a kind of immune system, like a artificial immune system. And what I've heard in Delhi, 4 people were given and 3 were recovered. So, like, but again, 4 is not a good number. If it is like 4,000 or 400 at least, I would say some. I would like to comment on that, but I don't know like where things are going right now. So the only thing we can do is like we do social distancing. We keep our hands and our surroundings very clean. Uh, Avoid touching face if you're going in mask. If you're going outside, wear mask, wear PPE. Doctors, trust the doctors, and they are doing their best. And yeah,
Absolutely. Very good. Anyone got one last one, or we'll call it a night if no one's got anything that's really burning them?
it's my pleasure. Truly, it's my pleasure. Uh,
Yeah. Thank you so much for coming out to visit with us and taking time to talk to these guys. I have this recorded, so I'll probably share the recorded lesson with the rest of my class so they can see the stuff that we talked about. And I'll
yeah,
share it with you right after I get off of here. So
okay.
thank you very much. I really appreciate you taking
Thank you.
time out and teaching us a little bit
Thank you for reaching out.
whole research experience. That's great information for these kids, these students. I mean, they're not kids anymore; they're adults
Yeah.
in about 2 weeks. So, yeah, we're gonna kick them up. Parents have their suitcases packed already; they're ready to ship them out to college. But yeah, thank you very
Right.
much. I appreciate you coming on.
Thank you so much, Mark, for your time and all your efforts. Thank you, kids, all of you for coming out. And I know you have some upcoming exams, right? AP biology, and you invested, I would say, almost an hour or something. I hope I didn't waste your time. I hope you got some useful information out of. Uh, Let me know if you have any questions. I think Mark already connected with me on Twitter. You can share that.
Yeah, absolutely. If you guys have more questions that come up, I'll email Dr. Sharma and we can exchange stuff too. So,
Yeah. Thank you. Good luck for your exam. Good luck for your work. Keep in touch. Thank you, Mark. Thank you so much.
thank you. Thank you
All
for
right.
coming out. Thanks for working with the times. And yeah, I will, as soon as I get off of here, I'm gonna figure out where this video got saved and I will send that over to you.
Okay. Thank you.
All right. Thanks, guys. I'll see you guys tomorrow at 9:30 in the morning. Last review session. See you later. Thanks.
Bye bye.